Okay, yeah, I guess we can get started now. So if you haven't read the announcement, what we're doing today is we will learn about web scraping. So let's get started. So think of this situation when you want to extract information from perhaps multiple websites, or you want to extract a large amount of data from a single website, but you have a limited time, so you don't have all day to work on this process. So what do you do? So now we will introduce web scraping. So what is web scraping? And we'll first just talk about the idea behind it. So web scraping is the automated process of extracting data from a website into your application. So why do we web scrape? So it is used when you want to collect large amount of information from a website, and because this is a automated process, and in 21st century literally everything is automated, so we can use web scraping technologies. We can organize the data into structured data, and essentially the big idea is just to borrow information from other websites and then turn it into your application. So there are many services we can use to perform web scrape. So there are online services and there's also APIs, but today we will be writing our own, which is the coolest method, and it is also the most flexible method. So we can basically do whatever we want without any restrictions. So now let's talk about the process of web scraping. So the first thing you do is you load and render a given URL, and it will just convert that into an HTML page. It will just be the HTML page of the website of the URL you want. And then we want to use a parser to convert the HTML page into different objects. And these objects is essentially just HTML elements, but in other languages such as like Python or Java, we can't just directly have any contact with HTML files. So now we want to use a parser to convert that into something that into an object we can use. And lastly, we will just use the parser to find information from our parsed objects, or just the converted HTML page. So now we can use this timeline thing, just the steps. So essentially, the idea is we have a web page right here. Let me go back. So essentially we have this web page right here, and we want to take this into an unstructured data, which essentially you can think of this as just the HTML file that is unstructured and it's meaningless. It's just a piece of text. And then we want to use web scrape. We want to perform web scraping. So essentially we're just scraping the data using the process of web scraping. And then this converts it into a structured data form. Essentially it's a data set of your scraped information, or you can think of it as something that's meaningful, which we can use in our application to do whatever we want. Now, you often hear about web scraping or web crawling, so they're not the same thing, and let's talk about the differences. So web scraping is the automated process of extracting data from sources such as the web. And web crawling is actually you want to download the pages from the web to discover URLs. So some websites might have hidden routes that we want to discover, and that's done through web crawling. And web scraping can be done at any scale. So it could be side project, or it can be industry-based. And web scraping doesn't follow something called a robot.txt, but web crawling, the robot that's performing the crawling has to follow this something called robot.txt. So what is this? So what is robot.txt? So it's also known as basically the robot's exclusion protocol or standard. So this is an instruction permission guide for web robots. Essentially, that the web robots would be performing the automated process of whatever you tell it to do. And this robot.txt would essentially just provides a list of available crawling pages and which pages you don't want the robots to crawl or discover. So now we will just discover some packages in Python. Well, why do we choose Python? Well, because it's literally the easiest language that anybody can just use and follow through. And we will discover there are 4 main packages used in web scraping. So the first one is Selenium, and Selenium is just a web testing library, and it can be used to automate browser activities. And this beautiful soup is we can use this to parse HTML and XML documents. And this can help us extract information from our HTML into data we can use easily. And next up is Pandas. Now, Pandas doesn't have to do with anything involved with the web. This is just a data manipulation or analysis software or package we can use, and we can extract and export it into our desired format in which we can use in the future. That's something useful, and they can all be used when we want to web scrape or web crawling. So next up, that's all the boring talk. Now we'll just do a live demo in Python. So what we will be creating today is a COVID scraper, and we will scrape data from this website. So I think I'll just wait a minute for people to set up a REPL project. And meanwhile, I think I heard something. So was it anybody had a question or never mind. Yeah, so I'm just gonna wait for like 1 or 2 minutes and then continue with how we can actually we will actually be using Beautiful Soup today to perform our web scraping project. So I'll just wait like 2 minutes if anybody want to continue. So yeah, all you have to do is just create a new repo. So I think everyone here used Replit before. And just create a new Python project, and then I'm gonna continue in like a minute. Yeah, sure, I can send the link. But essentially, you just find coronavirus count. It's literally the first one, but I'll link this in the announcement. Okay, so I think that's enough time for people to create a new REPL project. So I guess we can get started on first. We will just take a look at how to use Beautiful Soup on a local level. So we won't be worrying about how to get data from the web. So just a local HTML page. So you can just create a local HTML page. It could be anything. So just to demonstrate how to use Beautiful Soup first. So just create an HTML document, and I'm just going to change the title to my local document. Now, one thing we can use to import this HTML is just use the built-in multi-line string. So we can just say HTML equals, and for multi-line string, it's triple quotes. So like this, and this enables you to plug in a multi-line string. So essentially, we can think of this HTML as just a local Unicode string in our Python file. So we can get started. So first, we want to install Beautiful Soup. So if you go to the right and go to the if you click this shell, we can just run pip install bs4. So this Beautiful Soup actually comes in this package called bs4. So that's gonna take pretty fast to install. So you can just to test if you've installed this correctly, we can just add this import statement. So from bs4 import beautiful soup. Now it should autocomplete for you, but I don't know why. Okay, there we go. So yeah, if the autocomplete comes down, then this should mean you installed beautiful soup correctly. But you can also just run this file just to be safe, and it will also just install more dependencies. So just let Replit do its work. And if we run this, we don't get any error nor any output, so that's perfect. So what we can do first, we have to convert this HTML string into and parse it into an object, which is meaningful and it's easy to manipulate. So what we can do is just create a soup object. Now and then just wrap it in this function called beautiful soup, and we want this HTML string. So we just put HTML here, and then we actually want to say that this is actually an HTML document. So what we want to do is just on the second parameter, just pass in HTML parser. So like this. So now the soup is actually the HTML, but on a usable object. So let's see what we can do with the soup. So let's say I want to get the title right here, the title of my document. And what I can do is just set a title. I'm just going to set this equal to soup.title. Okay, let's print that and see what we get. Okay, so we get this entire title element. So remember that this title is actually a soup object. So it's not a built-in Python thing. So if this is an object, what's meaningful is that we want the string inside. So we don't really care the element this in HTML form. We just want the string in between. So what we can do is just run .string. So now if we run this, we would actually get the string version. So I'm just going to duplicate this twice. So you can just also add some comments to remind you. So this is actually the title object. Title object. So this includes everything that we can use. And then we can run this .string. Essentially, this just grabs the string in between. So I'm just going to say this is title string and string. So now if we run this title object will give us everything. And this .string, so this title string is only what's meaningful for us. Okay, so this if you don't remember from our second workshop, which we discovered some good programming techniques, we know that this is not a clean code. So what we can do is just, we don't want this to be a string. We want to import this from our HTML, and this also gives us more flexibility. So what we can do is just import this file and then just read it. So what we can do is just, we can initialize an empty HTML string like this. And then let's just read our content in index.html. And what we can do is just run. So with open index.html, so remember to wrap this in quotes. So index.html, and let's just call this as our HTML file. And then let's just set HTML as HTML file.read. So now this is the exact same, but now our code is much more cleaner and we can do much more stuff inside of our HTML file instead of a string in our Python file. So now if we run this, we will get the exact same thing, except it's just much more cleaner. Now you can also add comments just to tell you what's going on. So essentially we want to import our HTML file here. And then we create a soup object that converts our index.html into a usable object. So essentially that's this step right here. So load and render given URL, we didn't do that yet since this is a local HTML file. So So all we have to do is just get the HTML page, which is step 2, that's right here. And then step 3 is converting that HTML page into object. And the last part here is that we can use the parser to find information from our soup object. So this is what we can do if we want to find the website title. But the website title is definitely not interesting. So why don't we create something in our HTML page? So I'm just going to create a paragraph element saying something, hello world, like this. Now, to get this paragraph element, all we have to do is we can just say p equals soup.p. And what this gives you is actually the first occurrence of p, paragraph elements in HTML. Now, if you guys didn't attend the web dev workshops, p is just a simple paragraph in HTML. So we can actually just print p and see what we get. Okay, so we have our title. We can actually comment it out right here. So remember, if we just run soup.p, this p is this variable is actually a soup object. So what we can do is run .string, like what we've done with the title. So the string grabs the HTML, like the inner HTML in JavaScript. So from our last web dev workshop, I'm sure you've learned this with Arnav, like in JavaScript, but essentially this is the same thing. This .string is just whatever text is in between. And what do I mean by first occurrence? Well, why don't we create another paragraph text? I'm just gonna call this apple. So if we run, we'll still get hello. So this only grabs the first occurrence. So now, how do we find all occurrence? Well, there's a function we can run. So this is all paragraphs. And what we can do is just say this is all p's. And then we can run soup.find_all. So this function finds every single element. And then we can just run print all p's. And what this returns us is waiting to load. Okay, failed to connect. I am going to refresh. So let Replit do its thing. Okay, perfect. So this find all actually returns a list of elements or soup objects. And I didn't mention before, but there's really no prerequisites if you want to follow through. I'm sure everyone here used Python before, and literally all you need to know is how to work with list. And there's really no issues. I'm sure there's no issues with anybody here. So yes, all piece is just a list. So this is a list of soup objects. So if we want like the second one, we can just use in square bracket and just put in its index, and we will get apple. But what if we want the string? Well, we can also call that string here, because remember that this part is the object, and we can call that string to get whatever is in between, the content in between. So we get apple and hello world. That's the first. I can comment this out. So this is actually the second paragraph element. So as you can see, that's the second one here. We get apple. So this is essentially just the element. But in like a real HTML document like this, we can see it's a lot more complicated than just this. So first, why don't we see how to extract custom stuff? So we don't want to extract every single paragraph, so because that's not really meaningful. So most websites uses ID to essentially distinguish their elements. So why don't we create another paragraph? Now it doesn't matter what element you create. You can create a paragraph or any or header you want. So this element, it doesn't really matter. What matters the most is this string in between, because that's something we want to extract through web scraping and then convert it into something useful. So essentially, if we create a paragraph with an ID of, let's say, ID 1. So we can say this is ID 1. And we don't want all paragraph. Let's just say these are useless. We don't care what they are. We only want to extract paragraph with this ID of 1. So what we can do is just say, so first, this part is find by ID, is that we can say is ID 1. We can just, it's the same, we can just run soup.find, and then in our parameter, just pass an ID equals whatever we named it, which is just ID -1. And then let's print it out. So this would get us our paragraph element. Now we can also always run .string to get whatever's in the actual content, because remember, that's what matters the most. Yes, like this. Now, apart from ID, we can also find elements by class. So there's ID, and we can also have a class. So I'll say this is class 1. So essentially, it's the exact same form. So I'm just going to duplicate this. This is going to be class 1 now. And it's the same form, so except it's not ID anymore. Now it's class. But this is not going to work. And can anybody take a guess why this doesn't work? You can just put it in the chat. Okay, so this might be confusing to you if you're just learning Python, but if you've used Python before, you will know why this doesn't work. So anybody have any guesses? What we can find by ID, just say ID equals ID 1, but why can't we just say class equals class 1? Who have guesses why this doesn't work? Yes, that's perfect. So yes, class is a reserved word in Python. So that means it's just a word that we cannot use as variable or function and any other identifiers. So what Beautiful Soup did is essentially, if you want to find by class, just add an underscore after it. So now, if I comment this out, if you want to find by class, it's just class followed by an underscore. What's going on here? This, what if we just say class 1, none? Oh, right, sorry, my bad. So I forgot to change this to class. So yeah, so this should be class of class 1. So now, actually, yeah, that was a good example. If something you can't find, it will actually return none instead of throwing an error, which is essentially very hard to deal with. So that's kind of nice to have. So if there's anything you want to find that doesn't exist, it will just return an object of none. So yes, now we get our element here. So essentially, this is the most basic web scraping we can do with local files. So So, and now we can get started with working on our simple project. It's just a simple COVID scraper. And now you know how to use Beautiful Soup. When we are working with this project, it's going to be pretty easy and straightforward. So I can get rid of everything here. We don't even need this open anything here. Essentially, we need Beautiful Soup again to parse our HTML document. But in order to get the HTML from this page, what we want is we actually want another built-in package. So from request, import get. So this get is able to get our URL and then find the HTML. So what we can do is just create a variable of URL and just copy this here. And what we can do is we want the response. So we want the get to respond with our HTML, this URL's HTML file. So we're just going to say response equals get URL. So just get this URL. And now we want to convert this into a Beautiful Soup object that we can use to parse informations from. So we'll just create a soup equals Beautiful Soup, and then remember. So why don't we just run print response, and let's see what we get. So again, we have to let Replit do its work. Now I don't see why this doesn't work, but is request not a built-in function? Oh right, never mind. It's requests. Never mind. My bad. That was my bad. So we will actually want requests. So this thing, and why is this like this? Okay, so from request import get, what is this? Oh, I think I should just refresh because that's just a Replit being dumped. Okay, perfect. And what is this? Okay, so from requests import get. Why doesn't repo work? Okay, so yeah, it's taking a while for Replit to do its job, but if you want to use a local like if you want to use idle or PyCharm or even VS Code, go ahead. Because I'm just using Replit because I think most people have access to Replit instead of the other IDEs. But okay, now it seems to be working. I don't know why Repo decides to fail on me. Okay, so from Beautiful PS4, we want to import Beautiful Soup. And then just the same thing. Let's create an URL variable and just pass in our URL. And then we want to get our HTML file from this actual URL. So we can just say response equals get our URL. And if we print response, that's where we left off on response. There we go. So yeah, this response again is an Python object. Now this 200 means that it's a success. So what we want is that we want to get this HTML. So we can just run .text, and this will give us the HTML. And as you can see, I'm going to stop because that's going to take forever to load. But yes, essentially .text is the actual HTML file from our URL, which is what we see over here on the right if we inspect. So that's a good start. Now we just want to convert this into a usable object. So So it's the same process. So it's beautiful soup, and we want the HTML that is response.text. Now again, we want to parse this as a HTML. So just HTML.parser. Like this. Okay, so now we can get started and parse whatever we want. So we can get started. So let's just first find all coronavirus cases. Now you can press this button on the top left. Now you can just hover over whatever you want on this page, and then it will lead you to this div right here, on exactly where this is in the HTML. So as you can see, this is in the main counter number class. So why don't we see what is this first? So let's just create a container, this container essentially is just the soup object. So we'll just run soup.find. Now this is a div. So in this structure, we want to pass in what we want to find. So this is a div with a class of main counter number. So you can just double click this and then copy what's inside. So this find only finds the first occurrence, but what I realized that there's multiple main counter number here. So if you take a look at that, that's also, all of them shares the same class. So what we want is we actually want a list of them. So we would have to run find all instead of find. So if we run print our container, so response, sorry, my bad, spelled that wrong, but okay, that should be. Repo's being incredibly slow today. I don't know why, but that's cool. Okay, perfect. So as you can see, this returns a list of soup objects. So as you can see, these are the number we want. So that's probably all cases, and that's probably death, and then the third one is recovered. So that's really important to know. So now we can just parse this object into something useful. So let's just say right here, all. This is all cases, right? Yes. So I'm going to say this is all cases, and I want to set this as the container of the first item, or also index 0 if you haven't done if you haven't worked with arrays or lists before. So yeah, essentially it starts from 0. So, and then remember, we don't really care what this div or class is, we just want the number in between. So what we can run is run.text. Probably a good idea to print what we have. Okay, that's taking a while, so okay, perfect. So as you can see, we get our number now, and this represents all cases. So that's perfect. And now we can just do the same to the other two numbers. So death number, essentially we can just copy this, and this will be the second item from that container, and then the third one is our recovered. So recovered number equals, now this will be the last item, so that's container of index 2, and run.text. So now why don't we convert this into something let's express this number and make it nicely expressed on the terminal. So I'm just going to use f string and let's just say right here. So yeah, total coronavirus cases. I'm just going to use f strings because it's the most readable form. And then we want all cases right here. And then I'm just going to do the same for the other 3. And we want the death number and we want the recovered number. So total coronavirus death and then total coronavirus recovered. Okay, so let's run this and see what we get. So let it slowly do its job. Okay, perfect. So as you can see, total coronavirus cases is this, and if I refresh, as you can see, the number matches. So now we've actually scraped this data into our own project in which we can use in the future, like right here. So if you want to write down the comment, essentially this is the step 1. This is step 1, that is load our URL, and then right here is we want to parse this object, and then in here is we want to find the information, and then this part right here, this is the last block, is using the data we've extracted from this website. And obviously printing this is probably not the most effective way, but you can still call it using what we extracted. So that's just an example of what we can do. I don't know what happened was that, but okay, so now we get that, and why don't we also scrape the active cases and closed case. So essentially all we have to do is just get this element on the page, and as you can see, this is number table main. So now that's going to be another container. So just call this container 1. Now obviously you should use better names, like better variable names, but I haven't found a way to express this. You can call this this number object, but you can just call this container just to be more generalized. But most of the time your variable name should be more meaningful. So I'll just call this container 1, and let's run soup find all. Now it's just a tip from me that you should always use find all, because you don't know if this class is used more than once or more than twice. So just use find all. If it's only one item, it will just return a list with only one items in it. So there's really no harm. So let's just run find all, and this is another div. So we want the div, and we want the class that is number table main. So I can just copy this and then paste it here. And then let's just print this container 1 and see what this container 1 actually is. It might take a while, not because of Replit, but just from this request package is that we actually load this this page and then converts it into an HTML page file or HTML object. So yeah, as you can see, this returns a list with 2 items. And what are these numbers? Well, I think these numbers are the numbers here, the active cases and the closed cases. So that's meaningful. So now we can just use this information. So active cases, this will be our container 1. This is the container 1's first item. So we'll just run .text. And then the last one, or the second one, here. And this number represents the closed cases. So we can just say this is the closed cases of container 1.text. So we can just use them now in our application, which we can just print them out. So yes, active cases, and then I want active cases. Okay, there's no autocomplete, but okay. And then same thing, and this part is the closed cases, and then we want the closed cases here. So I don't want to print this container anymore. This print container is just, we want to see what's going on in this container or what's included. So we can get rid of that since we already know the numbers that represents this container. There, perfect. So we get active cases. That's this number here. That's not right. Give me a second. Closed cases. Closed cases is that. So, this number is active cases. Give me a second. Actually, I think that's right. No, active cases. Oh, this container 1. My bad. Yeah, see, that's exactly what I mean if you have bad variable names, but there's really no other names you can use to find these objects. So if you have a smarter way of naming these containers, go ahead, because you're supposed to use good variable names. Otherwise, you'll just make mistakes like what I did right there. Okay, perfect. So we get active cases. That's this right here. And then closed cases is that right there. So there we go. That's more information scraped from our website. Now another thing I realized is that there's somehow a space added here. Now we never asked for a space. Now what actually happened is if you take a look at what's going on right here, you will realize that there's actually a space right here after this. So you can always just strip this text if you've ever needed, since this is yours now. You can do whatever you want with this. Now we can always just continue scraping these numbers, and essentially it will be in the same, it's just the same technique like this. You first find the container of what these belongs to, and then you just get the text inside. Now what I want to scrape from an individual country. So let's say, let's just use the US for an example. Now as you can see, the URL is country, and then followed by a country name. So what I can do is just have a custom country now. So what we can create is a country URL now that is this right here. Except I want this to be custom, so I actually want the user to input whatever country they want. So why don't we ask for a user input right here? So just say country input, just something like enter country like that. And then we don't want the US anymore. We want this to be a dynamic URL. So we can just append whatever we've entered. Country input like this. Now it's going to be the same. They use the same class name. So as you can see right here, this is main counter number. And if you take a look at this, that this is also number table main. So this makes it very, very easy. So essentially all we have to do is just copy everything we have here and then just make some minor edit. So this URL is we don't need this URL anymore. We want the response now to be this country URL now. Country URL. And then everything else should be exactly the same. So let's just run that. Okay, so the first is our like the entire world's status of the current coronavirus. So now we can enter a country. So why don't we just try Canada? And these, as you can see, we can always just go ahead and check. So the route is /country/Canada. And as you can see, these numbers represents it's the same, right? 1 million, 1 million death. As you can see, they are exactly the same. But this is really poorly styled. So what I am going to do is I'm going to run some simple styles that I'm just going to print. Give it some lines in between. Now, if you have time, you can always make this, you can always style this better. But for now, I'm literally just going to make some lines in between them. And then I want this to be coronavirus cases. Now, this is not total. I'm just going to add the country here. So this is going to be the country input or whatever the user inputted. And then I am just going to copy this for all of them here. So we know that this is not like the global status. This is only for one country. So I'll just put the same here. Run this. Now, meanwhile, I'm just going to structure my code a little bit better. So from this point, this is for custom country, and this part is for global. So okay, so now I have some space in between, so that's good. So now we can enter Canada now. So as you can see, we will get total coronavirus cases. And in bracket, we have the country we've entered, that is Canada, and all the information we want. Now, if you want to continue, you can always just make this better or use this in an application that's more meaningful than just printing this out onto the console. So we can always, so the last thing I want to show you guys is, so Canada works perfectly, but why don't we try some other countries? So why don't we try US? So US doesn't work. So it says list index out of range. So let's take a look at why that happened. So country/US. As you can see, this container 1 at 1 is the closed cases. But as you can see, there is no active cases. There's really only one of them. So this doesn't work for all countries. And to conclude, I just want to say, I will just leave this as an exercise for you guys. If you guys come up with a strategy or to solve this issue, so you can always just put it in the Discord chat. So this definitely works for some countries like Canada that has the full statistics. Like Canada, I think Italy should be the same. So yeah, Italy have both active cases and closed cases, but like US, it's missing some data. So our scraper, or like our web scraper, doesn't know what happens if something is missing in this case. So yes, I'll leave this as just an exercise if you want to continue working on this. But before that, I just want to introduce some project ideas you can do with web scraping. So you can always make a price comparison app. So you can scrape from Amazon, eBay, and then just compare the price of them. Well, you can also make a price monitoring app. So just monitor the price of a product you enter. Now we can also scrape from social media, such as like Reddit or people's tweets or just some Facebook announcements. Or we can also scrape job listings. So like scrape jobs from Indeed or Glassdoor. And you can also scrape movie ratings. So you can just let the user enter a movie they want, and then you just scrape the movie's rating from like IMDb or Rotten Tomatoes. So yeah, these are like simple side projects you can complete, or you can also use them during hackathons. So this is basically it. I'm just going to conclude this workshop here. So I hope you guys learned something new. And I'll open the attendance soon. But before that, there will be no meeting next week it will be April break. The April break, and then just enjoy your April break, everyone. And feel free to leave now. Yeah, so have a good day, everyone.
Thank you, Andrew. See ya.